Good morning, friends. Today is the 9th day of the 21 days FDP program organized by NADCL Baramulla and ICR Atari Zone 8, Pune. So on this 9th day, we have our speaker, Dr. Rajesh Nehra, currently working in the Department of Animal Nutrition in the senior scale of assistant professor since 2014 under College of Veterinary and Animal Sciences in Rajasthan University of Veterinary and Animal Sciences, Bikaner. So he started his career as a training associate in Jawaharlal Nehru Krishi Vishwavidyalaya, Jabalpur, and also to his feather of caps, he was associated with the border security forces under the post of assistant commander under the Ministry
This
of Home
call is now
Affairs,
being
Government of India.
recorded.
And also in his research work, he is guiding 12 PG students, and also he is in the advisory committee of 20 PG and PhD students. To his credit, he has 30 research papers in national and international journal closely associated with the nutrition aspect of the small and large ruminants. So I heartily welcome all of you and the guest speaker, Dr. Rajesh Nehra, to deliver his talk on conservation of green fodders through hay and silages. Sir, please start.
Thank you very much. A warm good morning to all of you. I'm Dr. Rajesh Nehra. Our topic, today discussion topic is conservation of green fodder through hay and silage. So, different topics of discussion are the livestock census, 20th livestock census, and different initiatives for fodder conservation, and why we need conserve the forage or fodder. The two methods, hay and silage, their advantage, disadvantage, and what are the other possible method for the conservation of the fodder like haylage. So, as we discuss 20th livestock census, our total livestock population in our country is 535.78 million, and it has shown increase 4.6 over the last livestock census, which was held in 2012. The bovine population, which include cattle, buffalo, mutton, and yak, has shown increase about 1%, and the population of sheep, goat, and mutton grew in double digits, while the count of horse and ponies, the non-ruminants, pig, camels, donkey, mules, and yak has been declined. This is the pictorial presentation. You can see in 2007, 12, and 2019, the population figure of cattle, buffalo, sheep, and goat all has increased. The growth in goat population is higher. So, to fulfill the nutritional demands of these growing population of livestock, we have a acute shortage of feeds and fodders, and nowadays the current data released by IGFRI Jhansi, they told that about 11.24% shortage of green fodder and 23.4% shortage of dry fodder. As far as the concentrate is concerned, great race between rural and urbanization. People from rural area, they are coming to urban area, and urbanization is increasing. And the productivity of pastures is also declined. Earlier, we were observing that in rural area around the villages, there are land which are used for grazing of the animals. There is a common land. Almost all villages have such type of land, but nowadays the this type of grazing land is declining, and the productivity of the pasture is also declining. So another reason is diversion of land towards commercial crops. Changing land use pattern and diversion of land towards commercial crops. It means now farmers are focusing on uh, commercial crops, which are giving more income. And one another reason is the diversion of crop residue to other industrial uses. Even crop residue like wheat straw, paddy straw, they are using for making of bricks. They are using in broilers. So this is also a alarming situation, and this also increase the deficiency of the crop residue or feeding material of the livestock. And the non-availability of fodder seeds, then how can a farmer grow the good quality fodder? So this is also a important reason for shortage of the these fodders in our country. There are so many reasons, so many constraints. One of the major constraints to livestock and poultry production in India, in our country, particularly in resource poor rural areas where the farmers are keeping animal, is lack of feed and fodder for livestock. And this is the main reason for uh, reduced production. The scarcity accounts nearly half, just half of the losses in dairy production. If there is no scarcity, if there is proper availability of the feeding material, then we can increase the production. So another reason is human population increasing in very fast rate, and the land is available for fodder production or forest cultivation is also decreasing. I have showing uh, 3 states which takes measures to arrest the fodder shortage. In Rajasthan, in some districts, district collectors stop diversion of crop residue or diversion of herbs for non-agricultural use, such like bricks, and stops interstate trade of the fodder. Although sometimes it increase the cost of the crop residue, mainly in Western Rajasthan, crop residue are coming from Punjab, nearby state. But it is important to stop these agriculture waste or crop residue to use other than the livestock feeding. Some key initiatives for fodder conservation are improved fodder production, enhancing crop yield, and exploring alternative fodder resources. Conservation technologies, implementing techniques like hay and silage, and livestock feed management. We have to also focus on livestock feed management. We should stop wastage of the feeding material, and optimizing the feeding or precise feeding should be given to the livestock. Now come to the our main topic, conservation of the green fodder or forage. So why it is needed? It is needed to preserve feed at optimum nutritional value. It means when we have surplus green fodder, green forage, and it has the optimum nutrition value at the time of their pre-flowering or half-flowering stage. That time we can cut them, harvest them, and preserve them. And another is to shift available feed from present to the future. Today in Rajasthan, after monsoon, a lot of green foliage is available, but after 2-3 months or even after 1 month, during in winter season there is shortage. So we can use it in these periods. Another is to move feed from one location to the other location. Rainfall pattern is not equal in all India. In some states there are good rain, in some states are flood, and in some states green fodder is destroyed by heavy rainfall. So we can conserve these fodders, and we can transport it from one location to the another location. And it also assists pasture management. We can use surplus green forage, and it is important for the development of the pastures. And we also use these techniques to fill the feed gaps. Where in area there is surplus, we can use it for the places where there is shortage. And by this, we can use the surplus material for production purpose, or high yielding animals. And when there is drought and flood or any disaster, then we can use these preserved fodder. So conservation of these crops is also important due to seasonal variations. Seasonal variations create surplus forage at one point of the time, and that would be wasted if not properly harvested or properly conserved. So if you talk about the methods for conservation of forage or conservation of the fodder, the simple method is to drive off the moisture, and other is natural fermentation, and the driving of the moisture from forage from the basis is called haymaking, while the retaining the forage in succulent form and allow the natural fermentation, it is called silage. So first of all, hay. Hay is the product which is obtained by cutting and curing the entire herbage of fine or thin stemmed grasses or legumes. The moisture content of the product should not be more than 15%. Figure is 10 to 15%. In some books, it is also written 12 to 14%, but it should not be more than 15% at any cost. So what are the crops which are suitable for hay making? First thing is stem should be thin, so that it can be dried easily. So thin stem legumes, grasses like berseem, lucerne, leguminous berseem and lucerne, and among non-leguminous oat. These are the suitable crops during the Rabi season, during the winter season, and during Kharif season. We can use other grasses or thin stem crops. So many advantages of hay making are there. Hay provides the nutritious feed because it is prepared when there are maximum nutrients in the feeding material, maximum nutrient in the forage, maximum nutrient in the fodder. So it provides maximum nutrients which we can obtain from the green fodder, and it is used during the lean season, particularly in winter season. And another aspect of feed cost: if you have good quality legume hay, it may reduce cost of the production by replacing certain amount of concentrate. You know, the cost of concentrate feed is very high. Legumes are having good nutritional value, so we can replace concentrate also, and we cut the production cost. We can harvest these feeding material, these fodders, when there are maximum population of the nutrients in the plant, and we can balance the ration according to the availability of the good quality hay. We can reduce the cost of feeding. So what is the proper stage for harvesting of the crop, for making of the hay. As we know, the maximum nutrients are available in a crop or in a fodder crop or in any grass at the time of when they are at their mid-blooming stage, mid-flowering stage, two-thirds or half of the flowering stage. That time is the most suitable time. Maximum nutrients are present. After maturation or preparation of the seed, the feeding material goes to the nutrients are go to the seeds. So we should cut the crop at mid blooming stage. If in case of cereals the grains are there, then it should be in milk stage. And if you use the legume, then if there are some pods should be in tender position. Different type of hay according to the material, according to the crops, legume hay, non-legume hay, or mixed hay. Legume hay is the best hay because leguminous products have the maximum nutrients. So higher percentage of digestible nutrients like digestible food protein or total digestible nutrients. They are more digestible because having more leafy portion, high protein, and they are also rich in carotene, vitamin E, vitamin D, and also rich in calcium or other minerals. Whereas non-legume hay, as you know, the non-leguminous crops are having less nutrient than the legume hay. So they are less palatable, having less protein, but they may be rich in carbohydrate. And the crops in this category are oat, barley, and when we talk about the mixed hay, it is mixture of the both legume and non-leguminous crops. So now different methods how we can prepare hay. So most suitable is field curing, then barn drying, and artificial drying. Our aim is to reduce the moisture content. We have to dry the crop. So these pictures showing the field curing, stacks of hay in barn, and artificial drying by using fans or heat. First is field curing, as name suggests, name indicate. It is done in field, cut plants and cured in the field by using of the sun heat. The various steps are cutting the crop, any type of the power, hand cutting or machine cutting may be used. It is highly desirable to cut in the same direction so that repair of the hay is easy. Swath cutting, hay is dried much more rapidly in the swath than the windrows. After a certain degree of curing, there will be shattering and bleaching of leaves. So we have to take precaution regarding the curing of the crops so that shattering of the leaves, because leaves are having maximum nutrients, and bleaching due to the sun rays, they may be reduced. Otherwise, they reduce the nutritive value of the hay. As far as time is concerned, no definite time can be assigned, but you can see the intensity of sun and we can judge by the seeing the moisture content. It should be roughly 40%. After that, rakes are used. After wilting forage, about 40% moisture in the swath, it is rolled into small and loose, healthy cylindrical bundles known as windrows, and it is better to do raking in the morning as dew makes the hay a little more tough and prevent shattering. During the early morning, there is less chance of the shattering of the leaves. farmers are also using this technique, this procedure. Even they are harvesting their crop, which has been dry early in the morning, so that settling of the leaves or settling of the pods should be avoided. Pre-pod method. In this method is suitable in areas of high rainfall. As you know, during the high rainfall, there may be chance of the water logging. So tripod method, it is above the ground, and hay crop is spread on tripod for sun dry. Then baling and storing. Pick up baling directly from withdrawals in the most automated system. It can be done by laborers, and if you have the automatic system, it will cost the production, cut the cost of production. And where the baler attached to the tractor, pick up hay in the form of withdrawals and ball it. Nowadays, mechanized form of ball making is used. Second method is mow pouring, barn drying. We can use large barns for drying of the crop. So this refers the practice of pouring particularly dried hay inside the barn or in mows. Heated or unheated air, both are used, is blown on the mows until the moisture is reduced around 12 to 15%. It should not be more than 15%. Cloth pouring is completed in the field itself, and when the moisture is around 35 to 40%, it is taken into the barns and placed on the mows. Approximately, it will take 7 to 14 days. Generally, the hay produced in this manner will be greener and leafier, having more green color and more leaves, and of a high quality than field cured hay. Because in field cured hay, there is a chance of bleaching. So third one is dehydration or artificial drying. This is the process of soaking freshly cut or wilted fodder and drying in artificial dryers, but it is costly. Such a hay is considered of superior quality as it is done in controlled method, but it is costly. There are some losses during the hay making. There are certain causes. One is settling of the leaves. Leaves are important part of the hay, important material having more nutrition and like vitamins and minerals. So settling of leaves, the nutrients, mainly minerals or vitamins, are lost, and protein is also available in leaves. So protein and total digestive nutrient also reduced. So leaves are rich in nutrients, so we have to avoid settling during the hay making. Second is bleaching. It is due to over sun drying, and due to this, carotene and vitamin A is lost. Third one is leaching, and it is due to rain, and minerals and vitamins are also lost. Fermentation. Sometimes there is moisture and fermentation takes place. As you know, the plants respire even after harvesting, and due to fermentation, there may be loss of the starch, sugars, and they also produce some undesirable products. Oxidation may be there, oxidation of sugar, oxidation of the starch and the fat also. If you talk about the approximate losses in hay making, the loss of dry matter, it is around 20 to 30% in legumes and 10 to 15% in grasses. Loss of protein may be as much as 28%. Loss of carotene due to bleaching, it is also 19%, and loss of energy 25%. But these losses can be reduced. So, which type of hay is good quality, and what are the characteristics of a good quality hay? There should be a good aroma, a typical aroma of forage. When you go to the field and you see the process, you can feel the aroma of forage. And moisture content should not be there more than 15%. And it should be free from any foreign material like dust, molds, or any undesirable weeds. Because weeds are always available in fodder crops. So these should be avoided. And the color, reasonable green color, this gives a rough idea of protein content. If there is green color, certainly protein content will be high. It should maintain leafiness. Leaf should be there, like original fodder. When we harvest, there should be no loss of leaves. The loss of leaves during the process will produce a poor quality product. As we discussed, leaves have the more nutrients, and it should be palatable to animals. Legume hay contain 9 to 15% digestive protein, and 50 to 60% total digestive nutrient, while grasses hay, they contain less digestive protein and eaten as well. If there is unfavorable weather conditions, it is very difficult to obtain a good quality hay. So under such circumstances, hay is allowed to dry until about 50% moisture and has been removed, and then it is packed in sacks or piles. So fermentation takes place, and the hay may become very hot and turn brown. Brown color develop due to fermentation. But due to the fermentation, there is great loss of the nutrients. The starch are broken down in sugar and in alcohol, and a type of hay called mogrant hay is formed. And there may be chances of the growth of the molds, and they are also harmful for human and animals also. Sometimes it is cause hay fever. So sometimes hay stacks may catch fire spontaneously due to excessive fermentation because there is heat production. So moisture content should not be more than 15%, or it should be around 12 to 14%. It should be assured before the stacking of the hay. Now the second method for conservation of the green fodder is silage. Silage, this is a Greek word. It comes from silo, and then we defined it. Silage can be defined as a green material produced by controlled anaerobic fermentation of the green fodder with a minimum loss in respect of various nutritive constituents of the green fodder. So it is done under controlled anaerobic fermentation or natural fermentation. The process of conserving green fodder is called silage. Earlier silo were used, and it is a chamber. It is like a hole or pit in the ground where green fodder is stored for silage making. Now, crops suitable for silage making. In hay, we discussed that crops should have more leaf, thin stem, less carbohydrate, but for silage making, crops should have more carbohydrate, more soluble sugar, and they are mostly thick stemmed. And most suitable examples are maize, jowar, bajra, or like that crops which are having more soluble sugar. Nowadays, maize is more popular due to high yielding. So cultivated and natural grasses, they can also insult with addition of the molasses when there is less sugar or soluble carbohydrate is available. Mixture of grasses and other cereal fodders having less soluble carbohydrates and legumes such as berseem, they can also be used in ratio of 3:1. It means cereal fodders are used in 3 and legumes are in 1. Unwilted legumes, leafy fodder and dry forage, if you use, then ratio should be 4:1. Now stage of harvesting, the same stage of harvesting we use in hay making, because crop should be crop have the maximum nutrients at the mid flowering or milk stage. Now processes, how we prepare the silage. First is laboratory method of silage making. Under laboratory conditions, silage can be prepared by using polythene bag or small silos, like that. We can use plastic bags. Now, stage of silage. When we are do this in laboratory, we can use 45 centimeter into 60 centimeter polythene bag, and probe Susan for installing is shaft to the small 2 to 4 centimeter in length, and it should be wilted up to 35% dry mix and thoroughly mixed. Molasses, if needed, can be added into the availability of the soluble carbohydrate for efficient bacterial fermentation, and we can add 3 to 3.5% of molasses. Salt and urea can also be added. Salt at 0.5% level and urea at 1% level. So we can improve the palatability and nitrogen content of the silage. Then material is kept tightly into the bags, and the open end is sealed perfectly and kept in identical bags and placed in a metal can or any other sealing material. So these are the different silage preparation stages. Green crop, when grains are, this is the crop of maize, they are in milky stage. Then after harvesting, chopping should be done by using choppers, and after that, if you prepare small scale, then you can fill this by manual filling, and after that it is sealed. It should be airtight. There is no entry of the air, and it should be packed properly. After that, silage is seen like that, yellowish green, and this is the feeding of the silage to the dairy animals. So preparation of silage under field conditions. First, silo. Silo is an airtight structure designed for storage and preservation of high moisture feed as silage. Pit silos are more common, although nowadays mechanized form of silage preparation methods are used, but where the silo are used, then pit are dug according to the requirement, according to the animals and use of the silage. 1 cubic meter space is required for production of the 4 kg silage. So characteristics of the silo. The wall should be impermeable so that water cannot gain entry into the silo pit. Silo should be sufficiently deep. Silo must be located on an elevated ground. The size of the silo should be calculated on the basis of the number of the animals or need of the silage and length of the feeding of the silage. So different methods of preparing of the silage. First of all, selection of the crop. So select the crop that is to be instilled when it is 30 to 35% dry matter. Select the crop of the week when the weather is fair and not rainy. It is always better to soak the fodder first since packing is better. If you soak the fodder, then you can do packing easily. After chopping and ensuring that the dry matter is around 35 to 40%, then silo is filled with the fodder. If there is more moisture, then we can dry the fodder crops. The fodder should be evenly distributed throughout of the pit. And the top of the silo, the fodder should be packed 3 to 4 feet above the ground level. All sides should be covered with long paddy straw or poor quality grasses and then covered with wet mud and dung to seal the material, preventing the entry of the air and water. If you want to add, then salt can be added at 0.5% and urea 1%. For grass silage, there is less carbohydrate, there is less soluble carbohydrate, so we can add molasses at the rate of 3 to 35% to improve the sugar content and for better fermentation and ultimately to find the good quality silage. So there is fermentation in silage. So the principles of fermentation during the silage preparation, it can be regulated by increasing lactic acid formation by bacteria present on the fresh herbage or by adding of the preservatives such as sodium bisulfite or by direct addition of the weak acid solution. The first method, the soluble carbohydrate present in the plant material is fermented to lactic acid, resulting in a lowering of the pH. Our range is 3.5 to 4.2. The material of this type has a lactic acid content around 8 to 12% of dry matter and is described as well preserved silage or good quality silage. As long as the silage mass is kept under anaerobic condition, its pH ultimately will remain stable around 4 and the silage can be stored for longer time, even 3 to 4 years. So there are two types of Clostridium. When secondary clostridium fermentation takes place, one group cause a breakdown of the lactic acid with the production of butyric acid. Butyric acid is not desirable. The other group of Clostridia attack on amino acids, on protein, with the formation of ammonia, organic acids, amines, and carbon dioxide. Either or both of these types of Clostridia may become dominant in poorly preserved silage, which will have a comparatively high pH value. It may be around 5 or more. It is not desirable. So process, we can divide it in 4 phases. First phase, it is aerobic phase. Then we harvest the crop and we fill the silo or any bag. Then there is entry of air, entry of oxygen. So aerobic phase, plant enzymes are still working and they break down soluble carbohydrate to carbon dioxide and water. And heat is also produced In second phase, enterobacter species of bacteria act on soluble carbohydrate and produce acetic acid and lowering the pH slightly. The facultative aerobes are there. They use the oxygen, and now in this phase, it becomes anaerobic. In third phase, lactic acid producing bacteria, mainly the lactobacillus and the streptococcus species, they ferment soluble carbohydrate, which are present in feeding material, plant material. They produce lactic acid, and now pH also become low. In fourth phase, lactic acid production is on its peak, and it is stabilized to within the range of 3.5 to 4.2, and this pH is considered good pH for preservation of the crop or for making of silage. There are some changing during the fermentation process. As we know, plant respire continue for a short time after the material is packed in the silo pit. Enzymes, aerobic bacteria, yeast, molds, they become active until the oxygen is there. So first, we have to compress the soft material so that there should be minimum oxygen is there. The respiration also use up some of the carbohydrate in the plant material, and they give the carbon dioxide. And the temperature goes up to 27 to 38 degrees centigrade. Bacteria that are always present on the surface of the material, they become active and use up the carbohydrate and produce carbon dioxide and organic acids like lactic acid, acetic acid, maybe butyric acid, if Clostridia is there, and small quantity of alcohol is also produced. So two type of fermentation, lactic acid type and butyric acid type. In lactic acid type, when the fodder contains 65 to 75% moisture and sufficient sugar is available. In the plant juices, anaerobic lactic acid bacteria become active, and they produce eventually a good clean smell silage of high quality, very high quality. And in butyric acid, when crop is too rich with protein or proteinous substances, then butyric acid type of fermentation dominates, and butyric acid has a sharp, disagreeable, bad odor, and the silage is not released by the animal, and it is considered poor quality silage. So we use the crops which have more carbohydrate, less protein. The lactic acid checks the undesirable organisms, harmful bacteria, and particularly those bacteria which produce butyric acid. They are also inhibited by lactic acid. In butyric acid group, Clostridia group break down the protein in the plant material and produce butyric acid. So, butyric acid type fermentation should be discouraged. There are some important conditions, some important things which should be followed. First is moisture content. It should be around 35 to 65 to 70, and air should not be there. So it should be filled with great care, and excluding of air is important. So why exclusion of air is important? It is important to minimize the loss of nutrients due to respiration. If there is air, oxygen there, then respiration takes place and it will deteriorate the nutrients. It is also important to initiate the growth of lactic acid producing bacteria because they are anaerobic. And it is also important to prevent the development of undesirable aerobic organisms. If oxygen is there is chance of development of the aerobic organisms. And molds, they are also active during the presence of oxygen, and molds are responsible for spoiling of the silage, and it also makes unpalatable. And nowadays, aflatoxins are a big problem in concentrate, and if there is any chance of mold growth, then silage may also contain such type of toxins. So what's about the color of the silage? When the temperature in the silo is moderate, the silage tends to be yellowish or brownish green and golden color, golden green color. But due to high temperature, silage may be of dark brown or blackish color. So desirable color is brownish green or golden green. Now the AIV method of silage making. It is given name Professor A.I. Vitanen. He is from Finland and he developed this method, and he got Nobel Prize in 1945. So it is popularized that time, and even non-leguminous and other materials are also used for preparation of silage. And fusion was also successfully inside. In this method, acids are used as additive, and it was done by the Professor A.V. Vitanen, and that's why it is known as AIV method of silage making. Weak acids are used in this method. Some preservatives are used for silage making when there is less sugar in crop. Then fermentable sources like molasses, whey, buttermilk, or sour milk can be used as preservative. Less readily fermentable carbohydrate supplements, potato, sugar, wheat, grounded barley, they may be also used. Some acids like oxalic, formic, and lactic acid may be used. Minerals acids, sulfuric acid, it is used in AIV silage method. Chemicals, sodium metabisulfate, gases, carbon dioxide, and even formalin. Now the classification of the silage. It is classified by Shepherd and co-workers in 1948. Very good silage, and fair silage. So in very good silage, taste should be acidic and odor should be good. It should be free from butyric acid, molds, and chiliminase. pH of very good silage should be between 3.5 to 4.2. Nitrogen, ammonical nitrogen, it should be less than 10% of the total nitrogen. And lactic acid content should be more. And when we talk about the good silage, pH range is 4.2 to 4.5. Ammonical nitrogen range is 10 to 15% of the total nitrogen. And as far as taste and odor is concerned, acidic taste and very less than 2% butyric acid is in good silage. In fair silage, some butyric acid content, light proteolysis, and some molds may be there. pH more than 4.8, and ammonical nitrogen around 20% of the total nitrogen. So when we classified, these are the some parameters, and very good silage have the very less butyric acid, pH around 3.5 to 4.2, and very less ammonical nitrogen of the total nitrogen. Lactic acid content should be higher. Now, after hay and silage, a term haylage is also used. So, when grasses and legumes generally meant for hay are inside, mainly they are used for making of hay, but sometimes the inside and drum is haylage. It's between hay and silage. So, material wilted around 40 to 45% dry matter before insiling, and it is referred haylage. Straw can be used and chopped into fine pieces 2 to 3 centimeters. And as you know, the straws are lacking of protein or nitrogen. So 1 kg of urea, 1.5 kg of mineral mixture, they are dissolved in 20 kg of water and mixed with these feeding material and inside. And this is stored in silo pit like silage pit and is allowed to ferment under anaerobic conditions. And around 2 months, the pit are opened and fed to the livestock. It may be supplemented with 2 kg of green fodder per day per animal to take care of the requirement of vitamins or other minerals. It is not popular nowadays. Silage making is popularized. Another term is waste place. It is the silage containing animal organic waste like poultry droppings, poultry litter, swine excreta, bovine dung, and it is inside. So name is given waste place. This ventilage is anaerobically fermented animal waste containing other feed ingredients and with the help of lactic acid producing bacteria. So this is all about the preservation of the green fodder, mainly through hay and silage. So silage is nowadays popular. It has more benefits, and it can be used for feeding of the animals to increase the production, to fill up the gap of demand and supply. So this is all from my side.
Thank you, sir, for your presentation. Any participants having any query or questions? They can unmute themselves or can raise their hand also and ask your query.